Right. Maze walls. Obviously, we've just been hearing about how we should be able to, or it would be good to reduce the cost of building a maze, and it's absolutely correct that it's always been a major problem creating walls. So I thought I'd just go through how we built a half-size test maze. It's not necessarily the best way to do it, but it's how we did it. And as we're complete cheapskates, it didn't really cost a lot. Okay, so maze walls. Okay. So over the years, a lot of different mazes have been used. You know, for homemade bits and pieces. Let's disappear in a second. So starting in the very first competition, I'm not completely sure how this maze was built, but it looks very much like it was pretty fixed. There's a lot of there's no obvious posts in there, and there's gaps in the wall at very odd places where posts wouldn't be. So I would assume that this maze was fixed. This is obviously going to be in the end for a competition that requires different mazes to be revealed. The most expensive way of doing things, because you have to build the whole thing over and over again. I can only assume that they didn't expect that 40 years later people would still be running around these mazes. Okay. There we go. Okay, in 1980, the first UK mouse competition was run on a maze which didn't have any posts. Posts came later on. It used 3 different sized walls, and it had holes drilled in the maze which were around about 1 centimetre to 2 centimetres away from the wall. So it had the disadvantage that you had lots of holes in the actual base. And also, I'm not really sure that these things are particularly school friendly. Quite good for fending off muggers and things on your way home, though. Okay, so back when mice were real mice, and dinosaurs like this thing used to roam around the maze and could easily squash the maze. You probably did need a very solid maze. A lot of mice used sensors that dragged on the wall, and therefore would knock over walls if they weren't, very, very well bolted down. This picture on the left is our very first practice maze. And at that point, our mouse looked down on the top of the walls. So you can see it just comprises of posts and the tops of walls. There's no middle to it. This is the only picture I could find. It's probably the only picture that exists of this. So this would have been about 1984. I can see that board at the back is the pegboard that was on the wall in my bedroom at my parents' house. So yeah, that was a while ago. Okay, in 1985, I believe they may have sent it across in 1984, but it was for the 1985 World competition in Japan. Japan sent out all over the world several identical mazes so that everybody could have exactly the same maze when they got to Japan for the for the world competition. This was the first maze that we actually competed on that had posts, and I think it's where the maze that has been copied ever since. It used wooden posts with very, very thin slots in, and a thin piece of aluminium in the end of the the wood, which meant that, unlike a lot of the plastic ones today, the indent in the posts was a lot less than you get currently. Okay, so there we go. So the half-size competition was introduced first in Japan. Again, with the same construction of the maze. This time, I believe, in plastic, but with posts connected to the thing. The important thing really is that it looks like the original competition. And in fact, if you see a half-size mouse in the maze without any reference, it can be quite difficult to tell whether it's a half-size or a full-size maze. Okay, why would we want to have posts? Posts mean that all the walls are the same size. That helps when picking up a pile of posts. The only issues you get really with the three-size system is that it doesn't matter which wall you pick up, it's always the wrong one. So they're easy to do, and fast and heavy mice, they can be quite strong. If a mouse goes into the wall, they tend to come off the worse for it, as I'm sure Pete will agree. Okay. Right, removing the posts and putting magnets on the walls, which is what we did to create our half-size maze, has a number of advantages over posts. First of all, the plastic posts tend to snap. This pile of posts here is our current pile of broken posts from our full-size maze, and you tend to lose several posts on every outing generally. It makes it. Yeah, somebody trying to say something? Couldn't work that out. Nope, gone. Okay, the manufacture of the actual walls is a lot simpler because you don't have to put any shape on the end of the walls or lugs. They're just square pieces of wood, plastic, or 3D printing or whatever else that you try to create them with, which makes them a lot simpler. The only thing they need is a small hole in the bottom to place a magnet. Mazes are quick to set up because you don't have to put out all the posts. You don't have the problem of trying to push walls in between posts where they don't quite fit. They just sit on the main base. It's even easier to put the maze away because you could just get a giant broom and literally sweep them off the thing into a big bag, and you're done. There's no post to pull out, no post to break. Okay, and also because the base is flat and the posts are in the same place except every second place, it's possible to make a load of full-size maze walls in the same way and use the same base, so that you can have a full-size and half-size maze just on the same base, which hopefully would help make it easier to have both. Okay, so these are we made our walls out of UPVC trim, which is basically UPVC covered foam. It's very tough, and it's you can buy it, and it's very, very cheap. It's about maybe £3 for 4 or 5 meter strips of this stuff. I used this funny little table saw that Jim got me for my birthday a couple of years ago. It's a really simple thing. It's just a radio control motor with a big blade, but it's extremely good for cutting this type of foam. Okay, so you can just cut it to straight size, and that's about it. To put the magnets in the end, you can use just a drill bit with a handle, with a hand handle on, and a couple of turns the drill will put a perfect hole in the bottom to allow you to insert a magnet. Okay, what we found is that where the north and south of the magnet is important. If you're just using a wooden base, as we did with basically nails put in where the posts would normally be, you need. It doesn't matter which way round they are, though. We probably should create a standard. So in any end, on the walls, you've got 3 walls. One wall, the normal, which is the length of a single wall with 1 post on the end. That's used for almost the entire maze. You also need a long wall, which is a wall with 2 post lengths on the end. That's required just to finish off the ends of single pieces that are in the maze, to make sure that there's a post in the correct place. And the small ones, which are walls that don't have any posts on at all, aren't actually required to make any particular maze. They're just useful for being able to put in the middle of a corridor to block it off, whereas otherwise you'd have to take out a normal size one and replace it with a long one. So a few short ones is also useful. Yeah, the north and south. So on a post, we have a north-facing magnet, or a north-facing magnet that points down. The reason for that is that any wall that has a non-post, if the north is also pointing down, you can't put it next to that one, or the thing flies away. But if you have south at the other end, that magnet, meaning that they all jump into place. And in fact, it's possible to almost throw them into place. If you get the wall anywhere near where it's supposed to be, it flies to the correct position, which is quite interesting. Where are we? Okay. One thing we found quite difficult was actually to work out which was the north pole of the motor, and short of the magnet, short of actually sticking it on a piece of cork in a saucer of water, we found that you can get apps on your phone, if your phone's got a magnetometer in it, which will tell you that you've got the north side or the south side of the magnet poking towards you. Okay. Okay. The base, a bit like Duncan's one, we used a template. This template was printed out on an A3 piece of paper. We have an A3 printer, but you could use an A4 one. Obviously, the bigger you can make it, the more accurate it is. We just put the paper down, drilled a very small hole. The magnets used are only 3 millimeters thick, so you just drill a small hole that they can just dip down into at each of the points where the posts would be. Okay, and then we actually used a bag of nails, which I think cost about 75p, and we've still got about 90% of them left. The important thing is that the head of the nail is as close to the size of the magnets that you've used as possible. If you use a nail with a smaller head or a bigger head, it means that the walls can snap into place in a different, slightly off. So if you can get nails that have, in this case, we used 4 millimeter magnets with a 4 millimeter head on the nails, the walls always snap exactly to the right place. Okay, I think we've got a bit of, what's next? That's a bit of video, just of the walls. Yeah, throw them in. Yeah, and they just snap to where they're supposed to go. Okay. Okay, things we might do differently. As shown earlier, if a mouse hits this hits the walls, or at least a mouse the size of Thumper, which of course is considerable for a half-sized maze, it just runs over and knocks them over. So if you've got a bit more money and you want to spend a bit more on magnets, you could put the same magnets at the top as well as the bottom, and that makes the maze blocks stick much more firmly. The other thing you could use is something with a bit more magnetic pull, such as some steel, 4 millimeter steel pins rather than nails. But also, of course, you have to make sure that these things are magnetic, because not all nails, especially stainless steel ones, and not all pins that you might get, or steel rod that's 4 millimeters thick. It's very difficult to find out how magnetic it is before you buy it. But I'm sure we can find some of that. And I think that's about it. Any questions?
So how thick is the baseboard?
The baseboard, so I was just trying to stop. Where's this? Oh, there it is. Right. Stop that. The baseboard was just any old bit that we had lying around in the garage. So it looks like it's about 3/4 of an inch, maybe.
Yeah. So you have to use nails that are shorter than the thickness of the baseboard.
Yes, you do. Yeah. Yes. Yeah. Otherwise, it gets a bit dangerous with it sticking at the bottom.
It tells you having to cut them all, though, which would be a real pain.
Yeah. Yeah. You can get the ones we've got. I've got. They've for the size of the nail, they've got a very big head, so they're more like tacks. That we found worked fine. Okay, but we built a 9x9, and it took us a day to create that, with a lot of mucking about. The base took about half an hour, so just zip up. But they do all fit extremely well. One thing to remember is always to make the maze blocks ever so slightly shorter than they should be, because if you make them slightly longer, you end up at the other end of the maze with walls that are too long. But it's as a home maze, it's really good. And some of our maze walls are 3D printed. others are using that that UPVC. I suppose the only other improvement, that UPVC is only covered on one side because it's cladding, basically. But we haven't painted the other side. It's white-ish. It's just sort of slightly yellowy. But it doesn't seem to affect the mouse that we're running at the moment too much anyway.
Yeah, but that might not be acceptable for a competition.
Absolutely. No, in a competition, you'd have to paint the walls.
Okay.
I think we also used an ink pad, a red ink pad, just to go across the top. That's the sort that you'd use stamps in. So we found that really easy, just to go across the top to make it red. The tops don't need to be red, but I think it looks a lot better.
Okay. Any other questions for Derek?
Could you publish it? Oh, sorry, carry on.
No, Rob, I was just telling you, carry on.
I was just going to say, Derek, could you publish, I don't know, some sort of spec of the parts you've used? So the magnets, the walls, and the tacks.
Yeah.
Yeah, it'd be good.
I just wanted to say that one of my local DIY places, not B&Q,
the other one.
anyway, actually in the stripwood section, they actually have some planed finished pine that's 25 millimeters by 6 millimeters.
Perfect.
And you just cut the lengths off.
Cut it up.
There you go. And unpainted, it has reflectivity, which is very, very similar to what I get when I put my white PVC finish on it, which surprised me, but there you go.
Right. May change with time.
Is it fair to say that the magnetic encoders at any of your entries are not affected by the magnets?
Yes, that was. I've actually got a note of that, and I managed to miss it off, which was that one of the disadvantages, sensors possibly could be affected, but no, the magnetic encoders. Generally, the magnetic encoders are in the middle of the mouse, or at least behind the wheels. So I think they're far enough away. We've had no trouble. The mouse. I don't know if you've seen our bumper reconstruction mouse, but that uses magnetic encoders on the wheels, and those wheels are right next to the wall, and we have no problem at all. But it is possible, I suppose, that sensitive ones could be affected by the magnets, or you could use the magnets to work out where the edge of the walls were.
Another competition. Okay, Derek, thanks very much for that. That's quite interesting that there might be some mileage in that. Getting rid of posts and things that can be swept away easily, definitely attractive. Well, I think a prize to everyone who's managed to stay awake this long. We've managed to get ourselves through a whole afternoon, so thanks very much for that.